We have a two-way table to fill out here, some information that we need to fit in. Now we've got towns A, B, and C, and then along here, adults and children, and then totals tallied up. So here goes. 400 people were chosen in total. That's kind of the total of the totals. That's going to go here. 230 people were adults. It's going to be here. 55 adults were from town A. 65 children were from town A. 35 children from town B. And then 150 people were from town B. So from that, we can fill in the rest of the table. Here goes. So we know the total for town A. We can just add these two up together. We'll get 120. Then if I add up the totals for town A and B, I get 270. So if I find the difference between that and 400, it's 130. If I find the difference between the total and the adults, it must be 170 for the children. And then I could, what should I do next? Okay, let's work out how many adults are in town B. It's going to be what I add on here. It's going to be 115. Then if I add on 55 to 115, that's going to be 170. So this must be 60. And then finally, the difference between 60 and 130 is 70. If I add up this final row, I can just check that it is 170, and then everything must tally. So I get 100 from here, plus 70 is 170. Brilliant. One of the people is chosen at random. Find the probability that this person is an adult from town A. So we're choosing them at random from the whole population. So it's going to be 400 people. That's what we're going to end up dividing by. And how many are from adults from town A? It's 55. Absolutely fine to leave it like that. We don't need to simplify it or write it as a decimal. That's okay. For the second part, we are given that they are from town A. That basically means that it must be from here. So actually this time there's 120 people. Okay, all the rest we ignore because they're not from town A. Now find the probability they're an adult. Well, it's still 55 of them. So it's 55 over 120. Looking at the final part, for another survey, Jane wanted to choose a random sample from the 820 students living in a particular hostel. She numbers them 1 to 120 and generated some random numbers on a calculator. Here we go. Jane's friend Kareem used these figures to write down the following sample of 5 student numbers: 114, 142, etc. And Jane used the same figures to write these down. So which of these is not random? Well, we can see we're taking 3 digits at a time. So really, we'll ignore the 0. We'll take these, then these, then these, then these. And that is exactly what Jane has done. She's ignored 859. We'll talk about that in a bit. But that one seems okay. What's happened here? Well, how do we get 1? Well, we got 114, but then they've used 142. It's like they've used that 1 twice, and 4, 2, 8. So basically, the answer to part 1 is that Kareem's sample is not random. What can we say? We can say the second and last digit become the next numbers first and second digit. So you just have to point that out. You could also say that they're not independent. They depend on one another. I'll write that in brackets actually. Now, I commented on this a little bit. Why did Jane omit 859? Well, it's because there's 820 students. So just write there are only 820 students. Here you go, just add the 859. It's greater than 820. Brilliant.